Hello, good morning everyone. Today we are going to start class 10 electricity chapter. Our life has become much dependent on electricity. Today we cannot think of life without electricity. We are using in our day-to-day life so many things that is dependent on electricity. That means that works on electricity. For example, our mobile, our bulb, fan, refrigerator, many more things are there. When we start counting, we will not be able to finish up our list. Our life has become much dependent on electricity. When electricity goes for some time, how does it become? How uncomfortable we start feeling. So, when we talk about electricity, we must know from where this electricity comes, or how is that electricity generated, how is that electricity formed, what forms electric current. All these things we must know. So in class 9 we had studied, in class 8 and 9 we had studied about the types of charges. So what we say that the charge, there are mainly two types of charges, positive charge and negative charge. What we have? Positive charge and negative charge. This positive charge, how does it happen? From where does it come? This negative charge, from where does it come? This negative charge comes because of the electrons. This positive charge comes because of the protons. So what we will see in class 8 and 9, what we had studied, that when a body is rubbed over another body, then the bodies get charged. How does that body gets charged? That body gets charged because of the transfer of the electrons. The body which loses electron becomes positively charged, and the body which gains electron becomes positively charged. So in class 8 and 9 we have already seen that the glass rod, when it is rubbed over silk, the glass rod gives positively charged and then the silk gets negatively charged. When an ebonite is rubbed over wool, the ebonite gets negatively charged and the wool gets positively charged. So these positive charge and negative charges, they are the two types that we are going to study here also. And these two types of charges have got certain properties. For example, like charges, they'll repel each other. Unlike charges, they attract each other. That means oppositely charged bodies, they attract each other, and positively charged bodies, oppositely charged bodies attract each other, and likely charged bodies repel each other. So here in this chapter, in our class 10 electricity, we will see that this electric current is because of the flow of electrons. When these electrons flow, they constitute the electric current. They constitute. And when we are talking about the charge, then we see that the charge is the fundamental property. When we talk about the charge, then we can say that the charge is the fundamental property that is constituting the electric current. And when we are seeing about the charge, when we say about the charge, then we can also say that The SI unit of charge is coulomb. And electrons, they have got 1.6 into 10 to the power minus 19 coulombs of negative charges. Protons, they have got plus 1.6 into 10 to the power minus 19 coulomb of charge. So now let us see in this way that one electron is having 1.6 into 10 to the power minus 19 coulombs of negative charge. That means we can say 1.6 into 10 to the power minus 19 coulomb of charge is present on one electron. Yes or no? So 1 coulomb of charge is present on how many electrons? 1 by 1.6 into 10 to the power minus 19 electrons. So when we will take this up, it will become 10 to the power plus 19 by 1.6 electrons. Then what we will do, we will take here 10 by 1.6 into 10 to the power 18 electrons, and this decimal will remove, it will become 100 by 16 into 10 to the power 18 electrons. 4 4 is 16, 4 25 ja, and 25 by 4 is 6.25 into 10 to the power 18 electrons. So what we see, that 1 coulomb of charge is present on 6.25 into 10 to the power 18 electrons, and 1 electron is having minus 1.6 into 10 to the power minus 19 coulomb of charge. Sometime you are asked questions to convert this numerical, that means you are asked to find out how many electrons constitute 1 coulomb of charge, or 1 coulomb of charge is present on how many electrons. Thus in this way you can solve the numerical. Now our next part is about the conductors and the insulators. You all know about the conductors and insulators. Conductors are those materials, those substances that have got free electrons in them and they are able to conduct electricity. They allow electric current to pass through them. And insulators are those materials which do not allow electric current to pass through them. So examples of conductors, we have got metals, then graphite. In class 8 and 9 you have already studied difference between metals and non-metals, difference between conductors and insulators. Insulators do not have got free electrons, they do not conduct electricity. So all electrical appliances, or those electrical appliances in which we make use of electricity, their conducting material must be made up of such substances, such elements, such metals which are good conductors of electricity, or we can say best conductor. For example, we see silver is the best conductor of electricity, but being costly it is not used. Then comes the copper, aluminium, iron and so on. So in most of our electric wires, electrical appliances, we will see that the conducting material is made up of either copper or it is made up of aluminium. Next, our next topic is about electric potential. What is electric potential? Electric potential is defined as the amount of work done in moving a unit positive charge from infinity to a point. That means when charge has to be moved, when a unit positive charge has to be moved from infinity means from a far distance to a point, then whatever work is done, that work is known as electric potential. And our next topic is potential difference. What is potential difference? Potential difference is defined as the work done in moving a unit positive charge from one point to another point. That means it is not from infinity, it is from one point to another point. And one thing you must remember, that as we see the case of water, when we want water to flow from one point to another point, suppose you want that it is always you have got the supply of water in your toilet or in your bathroom, then what will you do? You will keep your water tank at the top always full, or always it must have more water. If suppose your tank is empty, will the tap give water to you? No. That means the tank must have water, then only your tap will give water. In the same way, water that we are keeping in the tank, if I keep the tank at the bottom and I keep the tap up, will water flow? No. In the same way, electricity, one case we will see that when we want a continuous flow of electric current, then there must be a difference in the potential, that we call is the potential difference. That means the one which will supply electric current must be at higher potential, and where the electric current has to move must be at a lower potential. So difference in the potential must be maintained. So potential difference we can say as the difference in the potential between 2 points. This is also correct. But the proper definition when we are giving about the potential difference, we say it in this way, that the amount of work done in moving a unit positive charge from one point to another point is known as potential difference. And potential difference, suppose we denote it by P or PD, and work done we denote it by W, and the amount of the charge moved we denote it by C, then PD is equal to W by C, or if PD we write by V, capital B, then capital B is equal to W by C. So this will be the formula for the potential difference. Potential difference is equal to W by C. And you know the SI unit of work is joule, and that of charge moved I have already told you as the coulomb is the charge, so joule per coulomb, and our potential difference we will take as volt or V. So 1 V is equal to 1 joule per coulomb. That means the amount of work done will be in joule, and coulomb will be in, charge will be in coulomb, and then the potential difference will measure it in volt. Next we have one thing more we can say, somewhere some places you may find as a charge moved as instead of C with Q, because C is the SI unit of coulomb, so better you can write W by Q also, then it is no problem. V is equal to W by Q. Now our next topic is how do we measure potential difference. Potential difference is measured with the help of an instrument that we called it as voltmeter. Next topic, electric current. What is electric current? How do you define electric current? Electric current, we define it as the rate of flow of charge. Rate of flow of charge. That means if I denote electric current with I and the charge flowing I denote it with Q and the time taken I denote it with T, then I is equal to Q by T. That means rate of flow of charge is known as electric current. Electric current is defined as the rate of flow of charge, where I is the electric current, Q is the charge and T is the time. If I write or if I say that the Q is equal to NE and T is equal to time only, the new formula comes, or we can say another formula comes, I is equal to NE by T, where N means number of and E minus sign means electrons. That means I is equal to NE by T. So you can use either this formula if you are given direct charge and time. If you are given number of electrons flowing and the time is given to you, then you can use this formula to find the electric current flowing. I is equal to Q by T and the SI unit of Q, that means charge, is coulomb and of time is second. So therefore SI unit of electric current is coulomb per second, and this coulomb per second is only known as ampere, and we write symbol as capital A. This part was not visible when I was writing, so now it is visible. I is equal to Q by T and SI unit of coulomb is C, charge is coulomb, that is symbol is C. SI unit of time is second, so C by S, C per S, coulomb per second, and this coulomb per second we call it as ampere. So SI unit of current is ampere. Small amount of current is measured in milliampere, and 1 milliampere is equal to 10 to the power minus 3 ampere. Still more smaller, less amount of current is measured in more smaller unit, where we call it as microampere, and 1 microampere is equal to 10 to the power minus 6 ampere. The instrument used to measure electric current is ammeter. Here I told you that the instrument used to measure potential difference is voltmeter. Voltmeter is having high resistance and it is always connected in parallel in the circuit, and ammeter, which is used to measure electric current, is having low resistance and it is always connected in series in the electric circuit. Now our next topic we will see. Our next topic is about the symbols of some of the commonly used components in the circuit. What are the symbols that we use? For example, we have an electric cell. We can see this side is visible. No, let me turn the camera a little this side. For example, we see the case of a cell. A cell is shown in this way, where the bigger one shows the plus positive end and the negative one shows the minus 1. The smaller one is shown by the minus 1. And if more than one cell will be there, we call it as a battery. And a battery is shown by combination of cells, because definition of a battery is only a combination of cells is known as battery. Now if we have a wire, connection of a wire, then we show it in this way. If a wire is crossing another wire, then we show it in this way. If we have a resistor, we show it in this way, constant resistor. If we have a variable resistor, then we show it in this way, or we can show it in this way. Actually, this is also used to symbolize a restart. It is used to. If we have an ammeter, we can show it with this. If we have voltmeter, we show the symbol this way. If we have an electric bulb, with this way. If the bulb is lighted, it is glowing, we will show this. If we have a switch, we can show it open switch in this way. If we have a closed switch, then we show it in this way. Or open one, we can show this way also. And closed one we can show by giving a dot also. This is, suppose this is open one, closed one, we show it in this way. So these are some of the symbols. Then we will see more as we study. Later on we will see. Let me see in your book what more they have given. Symbols, what we have done. Yes, these are only they have shown to us. Acha, more thing they have shown about the galvanometer. When we are showing this ammeter we are showing, then we have to show here also plus sign and minus sign, and this in voltmeter also. When we are writing, then you connect the wire and show the positive and negative one. In galvanometer also we are writing this way and we write G. One more thing, what is the difference between an ammeter and a galvanometer? See, when I was showing this part was not visible now. So this one is for ammeter, this is for voltmeter, and this is for galvanometer. What is the difference between an ammeter and a voltmeter? Ammeter also measures current, galvanometer also measures current. But ammeter measures and tells us how much, what is the amount, what is the measurement, that measurement is given to us. But galvanometer just detects the presence of electric current. It tells us whether the electric current is passing through that point or not. Okay. So in this one, what will happen in galvanometer? If I don't say, because it is just detecting about the presence of the electric current. So if we don't write plus and minus sign, then also it will be correct. Next we have, see, many numericals are given in your book based on these formulas. No. So about the numerical, when we have time, we will do the numericals separately of this chapter. Now we will do the next part. Next part is our how to get a continuous flow of electric current. That I already told you. To get a continuous flow of electric current, we must have the potential difference. One body must be at a higher potential and another body must be at a lower potential. Then only electric current will flow from body at a higher potential to a body at a lower potential. So in order to maintain a potential difference, we usually use a source of electric current. For example, we use a battery or we use a cell. Now we have direction of electric current. So the conventional direction of electric current is from negative terminal to the positive terminal. Or you can say in this way that earlier time it used to be a thought that electric current is because of the protons. So they used to tell that electric current flow from the positive to the negative. So conventional one, it was told positive to negative, not negative to positive, positive to negative. But electronic current, it is taken from negative to positive. So what we will say that the conventional direction of electric current is from positive terminal of a battery, to the negative terminal to the outer circuit. So when I will show you the circuit diagram, that time I will show you. Now we have our how the electric current flows in a wire. When electric current is flowing through a wire, then when electric current is not flowing, when the electric current is not flowing through a wire, let me rub this part. When electric current is not flowing through a wire, then the electrons in this wire, they are going in any manner. They are not arranged in a proper way. Wait, let me rub nicely. When in a wire the electric current is not flowing, then the electrons inside that have no fixed direction. These electrons may be moving in any direction, we can say. The electrons have no fixed directions. They keep on moving in any manner, any way they want. But once we start flowing electric current through them or through that wire, then the electrons get aligned themselves, they arrange themselves, and then they become in this way. Or you can write so this up head. Okay. So what we are seeing that when the electrons are in such a stage when the electric current is not flowing, then they are going in zigzag manner, in any manner. They are not in a fixed proper direction. They are moving in random direction. But when they are connected to a source of electric current, say let us say a battery, or a cell, then what will happen? When it is connected to a source of electric current, then they start moving from negative end to the positive end of the wire. From negative end to the positive end of the wire. So what will happen? Suppose this is my cell and this is the source of electric current. This is negative, this is positive. So in this way it will start flowing, and hence it will start getting arranged, or the electrons get arranged in such a way that they are going from negative end to the positive end. But the conventional electric current, what we had seen earlier, that the conventional electric current is from positive end to the negative end. But the electronic current is from negative end to the positive end.